Hello, good day, and welcome to this video. We are going to be learning the second case of propagation of errors in multiplication and division, and the second case is definitely division. So today is for learning about division. Now in the last video we learned about how errors propagate with multiplication, so we're going to learn about how errors propagate with division. So let's say you have two quantities, a measured value and its approximate error represented like this: x plus minus delta x divided by y plus minus delta y. Okay, then you want to find the outcome of this division. Let's assume that the answer is z plus or minus delta z. Now z is the actual value of let me say z is the dividend, then delta z is actually the approximate error that results from this division. So we are going to use mathematical assumptions and formulas to obtain the value of z and delta z respectively. So the first thing I'm going to do is z plus minus delta z is equal to this. Over here we have x plus minus delta x, then I have y plus minus delta y to the power of minus 1, of course by law of indices. Then you have z plus minus delta z is equal to you have x plus minus delta x, then I'm gonna factor out y like this. So let's go gradually: y, then 1 plus or minus. So y takes out y from this, you get 1. So y takes out y from this guy, you're gonna get delta y over y. Is that okay? Then you have negative 1 here. So this is still the same thing as x plus minus delta x, then into, then what happens to this place? A raised to the power of n times b raised to the power of n is still a b raised to the power of n. Okay, remember that law of indices. So that means this power can be distributed to these two terms. So I have y to the power of minus 1 and 1 plus minus delta y over y to the power of minus 1, like this. So of course, how can I interpret this term relative to this term? It's still the same thing as you saying 1 over y of x plus minus delta x, then 1 plus or minus delta y over y to the power of minus 1. Remember that y to the power of minus 1 is 1 over y. Is that okay? So this is what we have now. So the interesting part about propagation of errors by division comes when you get to this term over here. So this term is our term of interest, this term over here. So we are going to use binomial expansion to elaborate the nature of this term, but don't be scared, we are not going to do any long binomial expansion. We'll just use what is already existing. Now you have to just recall that 1 plus x to the power of minus 1 is an infinite series, like this: 1 minus x plus x squared minus x cubed plus x to the 4 minus x to the 5, then plus so on and so forth. So it keeps going. You see the sign is like flip-flopping. So on negative on odd powers, okay, that's 1 3 5 7, we have a negative sign, and on even powers 2 4 6 8 10 12, we have a positive sign. And the first term of this power series is unity, that is 1. Now we're going to apply this power series to this particular place over here, taking 1 as 1 and taking x as this value. X is plus minus y over delta y. So this is what I want to establish, that 1 plus or minus delta y over y can still be taken as 1 plus minus delta y over y. Okay, so I want to be careful enough with the sign conventions. That is why I'm going to employ it like this. Okay, so plus is like a neutral sign in mathematics. So we have 1 plus or minus delta y over y. Okay, so it will not really change what is happening. So let's apply it to this guy over here. So we now have z plus or minus delta z is equal to 1 over y and x plus minus delta x. Then I'm going to apply this power series to this term over here, Okay, so in applying a power series to this term over here, this changes to this. Okay, it's still basically still the same thing. So anywhere I see x in this power series, I'll just replace it with plus minus delta y over y. So the first term is 1 and minus, I have plus minus delta y over y, and plus minus delta y over y squared, and minus plus minus delta y over y cube, then plus, and so on and so forth. It keeps going like that. So this is the power series representation of this particular second term in the that's this particular term over here. So we've converted it to the power series equivalent. So our z plus minus delta z is, we have 1 over y and x plus minus delta x. Then something interesting happens here. Now you need to know that this quantity over here, delta y, is extremely very small. Now what will happen to delta y squared? It will be smaller. Delta y cube will be smaller. Let's say delta y is 0.001. So when you square it, you get 0.001 squared, which is going to give you something like 0.000001. You understand? So this is how it keeps decreasing. When you square numbers that are very small, they actually reduce in size instead of increase. Okay, so y cube will be even much more smaller than this guy over here. And the thing is that we are not just squaring the numbers, we are squaring the numbers. Like in this term, we are squaring delta y and we are dividing by y at once. So think about it. Y is probably big, but delta y is very small. So when we square and we divide, you understand, the bigger the denominator in a particular division, the smaller the result, coupled with the fact that we are squaring. In fact, all the grammar I'm just saying is that we are neglecting all these terms, all the terms of higher powers. So the only term that is significant that we can consider is these first two terms, but any other term that has a power other than 1 can be neglected in this power series expansion. So you can actually test that with your calculator. Then for instance, I can give you that y is 0.01, then y itself is 8. I want you to try to test how small the outcome of these divisions will be when you carry that. So you see for yourself that they are less significant and we can neglect them. So I just have to deal with this term over here, plus minus delta y over y. Okay, like this. So I have z plus minus delta z is equal to 1 over y and x plus minus delta x. Then I have 1 minus plus or minus delta x over x. Actually, when we are solving this kind of mathematics, we should be very careful with sign conventions. Now, for the purpose of consistency, I can still replace this as, let me see, minus or I'll replace minus into plus minus delta y over y. What does this mean? This has more meaning, more than the syntax of mathematics that we know. Okay, it has more meaning to the syntax of mathematics than we know. And in one of the previous videos, I was able to clearly explain the effect of negative signs on ranges. You know, anytime you see plus or minus 2, we are actually talking about a range of numbers, perhaps between, that's a range of numbers between 2 and minus 2. So what happens when you now introduce a minus sign to this particular range, okay, of numbers, or to this particular range of numbers? So when you introduce a minus sign to this particular range of numbers, the minus sign does a number of things to this range of numbers. And like an inequality, for instance, when you have a is less than x less than b. So when you introduce a minus sign to this inequality, for instance by multiplying through by minus 1, you have minus a is greater than minus x and is greater than minus b, which we can still write as minus b is less than minus x is less than, okay, minus a. So in the first case, without the minus sign, the range of values was from a to b. Now in the second case, with the minus sign, now the range of values is now from negative b to negative a. So what do you observe? The effect of minus sign on ranges is simply two things. It first of all, it reverses the limit of the range. The upper limit becomes the lower limit, and the lower limit becomes the upper limit. It doesn't just reverse the limit of the range, it actually introduces a minus sign to the range. Is that okay? It introduces a minus sign to the limit. It kind of negates their values. So when you negate a negative value, it becomes positive. When you negate a positive value, it becomes negative. So that's the effect of minus sign on ranges. And we see that if I apply it to this particular place, I will just simply replace, instead of me having a plus or minus, I'll have a minus or plus delta y over y. You understand? But still take note that these are magnitude values. Okay, these two, they are magnitude values. That's what they mean literally. But let's keep going. So this is 1 over y. Then I'm now going to expand this. So in expanding, I'll have x times 1 is x, and this x times this value, I can say minus or plus x delta y over y, like this. And this times this is going to be a plus or minus delta x, and this over here times this over here, let's just say it's a plus or minus. Okay, plus or minus delta x, then delta y over here, this way. Okay, so this mathematics, you have to be careful with sign conventions, although for now there are no much rules as to working with this kind of stuff, but I'm just trying to do it as much as possible to a way you understand. Now delta x times delta y will gradually tend to 0 because delta x is very small and delta y is very small. So when you multiply both of them, they will be much more smaller than the individual values. And you're also dividing by y on top, so it's actually going to be small. I can neglect this last value over here. So we are just left with z plus or minus delta z is equal to 1 over y. Then we now have over here, we have x, then plus or minus delta x, like this, then minus or plus x delta y over y, like this. Is that okay? So we have z plus or minus delta z is equal to, when you open the bracket, you have x over y, then plus or minus, we have delta x over y, then minus or plus delta x delta y over y squared, like this. Is that okay? So there's something that happens here. Now still in the last video when I was explaining the effect of negative sign on ranges, because of what happens internally in this particular range, whenever you see something like this, plus or minus delta x or plus or minus delta y, it actually creates what we call a tolerance interval. Okay, so when you do this and you do this, when you bring them together, they actually still add, they will still add up together. Okay, because since we have taken care of the fact that of where the negative sign, of how the negative sign affects a particular interval, we've taken care of that in this particular term previously when I was trying to explain all of this. Now what happens to this term and this term over here? What do you think will happen to them eventually? Well, actually these magnitudes will still eventually add up because these are magnitude terms. Okay, and if you want to understand it, you have to remember propagation of errors in addition and subtraction. So z plus or minus delta z is equal to x over y. So what I'm saying in essence is that I can actually replace this particular two signs. I can just collect a single plus or minus to represent them. So I can now have this guy over here as delta x over y, then plus x delta y over y squared. Is that okay? So check this out. If you compare the measurement part to the measurement part on the right hand side, you discover that z is equal to x over y. And if you compare the error part to the error part, the error part on the left to the error part on the right, you have that your delta z is equal to, so my delta z is equal to, so to establish a more consistency in this particular one, I'm going to use a modulus sign. Okay, the magnitude of this over here then plus x delta y over y squared, like this. So this is what I am going to do. Now this magnitude of z over here is called our absolute error. So this is the absolute error in measuring a quantity z, that's after the two terms divide. But this absolute error formula is kind of like pretty hard to remember. That is why we still proceed to get what we call the precision relative error. Now if you remember from one of the last videos that I did, I said if you have a quantity z plus or minus delta z, if you want to find this term already is the absolute error. If you want to find the precision relative error, you just need to divide this term, the absolute error, by this quantity here, z, and that's exactly what we are going to do here now. So we are going to find delta z over z in this particular term over here. So we have delta z over z is now going to be, let me see, 1 over z multiplied by this guy over here, which is delta y over delta x over y, then plus, what do we have, x delta y over y squared, like this. Is that okay? So remember that z, we've gotten z as this particular thing, we got it by comparing measurement parts to measurement parts, then error parts to error parts. So z is equal to x over y. Z is the dividend, like I said earlier. So if z is x over y, 1 over z is simply the reciprocal now. That's y over x, right? So that's what I'm going to apply in this place. So I have delta z over z is equal to 1 over z. Sorry, I was trying to write that z is equal to x over y. So therefore 1 over z is equal to y over x. So delta z over z becomes 1 over z is y over x multiplied by, I have delta x over y plus x delta y over y squared, like this. So we have delta z over z is equal to, so if you open these brackets, this is what you're going to have. These constants can be distributed into, there's a formula in absolute value that said a into b plus c, still the same thing as absolute value of ab plus ac. Is that okay? Where a is a constant outside. So when we open this expression, this way we are going to have y will cancel out y. Is that okay? Then I'll have delta x over x here, then I'll now have plus, when you open this one and this one, x will cancel out x, y will cancel out 1y over here, then you now be left with what? Definitely be left with delta y over y, like this. Is that okay? So when you open the brackets, this is what you should get. Then you have to remember sub of absolute values. It states that when you have the absolute value of a plus b, it's less than or equal to absolute value of a plus absolute value of b. So delta z over z will now be less or equal to absolute value of delta x over x, I'm sorry about that, plus absolute value of delta y over y. Is that okay? So you can now see that this is exactly the same thing that we got for this is exactly the same thing that we got for multiplication. Is that okay? This is the same thing that we got for multiplication. So division and multiplication summary: whenever you have a quantity x plus or minus delta x and y plus or minus delta y, both division, okay, our z plus or minus delta z, in the case of multiplication, we'll have, let me just open a bracket, multiplication, our z will be equal to xy, then my error, or let me use my relative error, delta z over z will be less or equal to delta x over x and plus delta y over y. So both multiplication, then division, sorry, in the case of division, z will be x over y, then delta z over z will still be less or equal to delta x over x plus delta y over y, like this. So this is this propagation of errors in division and multiplication. So don't forget to like, subscribe, share, hit the notification bell, and stay updated. In the next videos we'll be solving practical examples. Okay, bye. I'm rushing because of my battery.